Hello, everyone. How's everyone doing today? Alrighty. Very nice. My name is Samartha Chandrasekhar, and I'm a product manager in the AWS Compute organization. And with me is Galen Emery, manager of solution architects at Chef. And today, we're going to be talking about Amazon Linux 2, our stable, secure, high-performance Linux environment. I'm going to get started talking about what Amazon Linux is, what Amazon Linux 2 can do for you, how you can get on to using Amazon Linux 2. And then later on, we'll have Galen come talk about Chef's experience with certifying their applications on Amazon Linux 2 and the possibilities with their application suite and Amazon Linux 2. So we'll get started with the history of Amazon Linux. Some of you might be aware, we first launched Amazon Linux as Amazon Linux AMI in 2011. This was about 7 years back. And every 6 months, we put out a major release of Amazon Linux AMI that included the latest and greatest innovations from the Linux community, as well as support for the latest EC2 platforms and capabilities. It was optimized for use on the AWS cloud, and it was only available for use on the AWS cloud. Now, we've been successful, phenomenally successful with Amazon Linux AMI, and we have a very large amount of usage on EC2 with Amazon Linux AMI across customer segments spanning startups to enterprises to public sector entities. And we've seen usage across a broad spectrum of workloads from containers to big data to deep learning to web stacks to line of business applications, you name it. In fact, this is most evidenced by the fact that as you see this wide portfolio of AWS services, such as EMR for your big data applications, for things like, we've had things like deep learning armies, where we include deep learning frameworks into the OS and provide it as an army. We've launched things like .NET Core armies, et cetera. All of these are mostly based on Amazon Linux AMI. Now, as many of you all are aware, we work backwards from our customers, and 90 to 95% of our roadmap is really driven by what you, our customers, tell us. And we got some super actionable feedback from you all. We heard that you wanted long-term support for 5 years to be able to use this in sort of these long-running enterprise settings. You said you wanted access to bleeding-edge software in addition to getting a stable, supported base OS. There's historically been this trade-off that you had to do, where you either get a stable, supported base OS that is conservative when it comes to the availability of application software, or you get this super bleeding-edge operating system where you don't get things like long-term support. So you asked for a balance between that. You asked for the availability to use Amazon Linux, not just on the AWS cloud, but also on premises in your own local data centers and on your laptops. And you also asked for a robust ISV ecosystem, where you could be rest assured that the ISV software that you were using was certified and supported for use on Amazon Linux. Now, we've answered your calling earlier this year. In roughly June of this year, we launched the long-term supported version of Amazon Linux 2, which is the next generation of Amazon Linux workloads. So when it comes to what's in Amazon Linux 2, it comes with enterprise-grade long-term support for 5 years. It is optimized for use on AWS, and specifically the EC2 runtime. And it's also universally available. It's available not just for use on the AWS cloud, but also on your VMware environment, on Hyper-V, on KVM, on VirtualBox, et cetera. It's also available as a Docker base image that you can use in any Docker environment. And the best part is that it is available at no cost. Now let's deep dive into each one of these topics, starting off with long-term support. Now, we launched roughly in June of this year. So 5 years out, you'll get long-term support for 5 years until June of 2023. And this not only includes security updates and maintenance fixes, but this also includes things like binary compatibility, specifically ABI interface compatibility, the application binary interface compatibility for core packages like glibc, like Java, like OpenSSL, et cetera, et cetera. There's a long laundry list of it. So that you can be rest assured that your applications that depend on these core packages will continue to function unmodified and not be affected despite these underlying packages getting updated, be it security updates or maintenance fixes or things like that. So these are essentially compatibility-preserving updates that we're promising for the duration of 5 years. The other important point to note here is that we have AWS support plans that you can use to get premium and phone support. If you already have an AWS support plan, you get support, and when I say support in this context, I mean premium and phone support at no additional fee for Amazon Linux 2. Now, when we sell AWS support plans, these aren't sort of demarcated based on what services or products you're buying support for. This is typically across the board, so it includes support for all AWS services and products. And if you already have it, or if you're going to purchase it, it also includes premium phone support for Amazon Linux 2. Java support. We realize Java is super important. We at AWS are big users of Java, and we know that a lot of our customers are as well. There have been lots of recent developments in the Java community regarding the availability of long-term support. Now, I'm here to reaffirm that the Java that is available in Amazon Linux 2, which is currently stock OpenJDK 8, will continue to get long-term support until June 2023, which is the duration for which the OS will get long-term support. In addition, we've also announced that OpenJDK 11 will be made available in Amazon Linux 2 going forward. Now, in addition to stock OpenJDK, as Amazon and as AWS, we've also announced that we have our own first-party OpenJDK distribution that we call Corretto. And Corretto will also be a no-cost, long-term supported version of Java that will be production-ready shortly. Right now, we have a preview of Corretto that is already baked in and built into Amazon Linux. And again, all of this is available at no cost. Amazon Linux is also optimized for use on AWS. We have a modern kernel. This is Linux kernel 4.14. And we've done a lot of work to ensure that it is optimized for use on EC2. You might have heard of the announcements last night with regard to the availability of ARM virtual machines as A1 instances. So Amazon Linux 2 supports the A1 instances that are powered by the AWS Graviton processor. You also might have heard about announcements regarding Firecracker. I'll get into some of that shortly, but we also have support for Firecracker. So generally the latest EC2 platform capabilities are enabled as inbox components. And this also includes things like agents for various AWS services. One of my favorite agents that is in the Amazon Linux 2 army is the SSM agent. SSM is AWS Systems Manager. And one of the capabilities that it provides is called Patch Manager. And this provides you with the ability to patch your fleet of virtual machines running Amazon Linux 2 or any other OS that has the right agent installed in an automated manner. It also has a single pane of glass that lets you monitor the patching status of each virtual machine in addition to, with your permission, performing automated patching on subsets of them. Amazon Linux 2 can also run on EC2 bare metal. This is our EC2 instance offering where we provide you with a bare metal physical server as opposed to a virtual machine. And it can operate on EC2 bare metal not just as a bare metal OS, but you can also use it as a virtualization host. It comes with KVM, kernel virtual machine, the virtualization software that you can enable and use it as a virtualization host. The other noteworthy thing here is that with KVM, you can also use it in nested virtualization mode. So you can have virtual machines and have virtual machines inside those virtual machines with nested virtualization turned on in KVM when you're using Amazon Linux 2 on EC2 bare metal. Now, some of these, when we say optimized for AWS, some of these are things like including things like drivers and agents and supporting new EC2 platform capabilities. But we go much further than that. In fact, in some cases, things like kernel configurations and settings have been tuned based on our intimate familiarity with the EC2 virtual machine specifications and sort of the instance types and families and things like that. So in many cases, although it might not be super obvious, there's months of work that has gone in to make these optimizations and this and to ensure that Amazon Linux 2 runs super well on EC2 instances and to make that happen. Now, before I proceed on to the next slide, I want to show you a quick demo of Amazon Linux 2 running on the brand new A1 instances that we just announced. So what I have, this is going to be slightly quick. So I'm going to switch over to my demo machine here and connect over into a virtual machine that I have running on the A1 instance. So I was able to log in. Let me just go ahead and increase the font size so that folks at the back can look at it as well. All right, can everyone see the screen? All right, so this is going to be quick, but what I want to show you here is that this is an ARM build, an ARM64 build of Amazon Linux 2 running on the brand new A1 instance type that is powered by the AWS Graviton processor. The best way to do that, so I'll do a uname -a. So this is Amazon Linux 2 on ARch, and then I'm going to do a ls CPU. So there we go. This is running on ARM64, our brand new instance type on our first-party processor. Again, OS demos are never really eye candy, but I have more demos lined up to show you some cool capabilities. Switching back, I also want to talk to you about extras in Amazon Linux 2. Now, there's historically been this trade-off in the Linux ecosystem where you've had to balance between OS stability and software freshness. Like I was mentioning earlier, there is typically the choice you need to make between a stable OS that gets long-term support for 5 years or 3 years or something like that, and access to the latest and greatest application software. It could be things like language runtimes. It could be things like databases. It could be configuration consistency tooling, etc. Now, with extras in Amazon Linux, this is a new concept that we've introduced. We're giving you a mechanism to consume bleeding-edge application software on a stable supported base OS. So with Amazon Linux 2, we have a subset of the OS that we call core. And this alludes to the core set of repositories that you can access via yum, that or Yellow Dog Updater modified, the tool most RPM-based Linux distributions use. And for that core set of repositories, you will get long-term support for 5 years. Now, we also have this other channel to provide you with software that we call extras. And this is essentially an AWS curated list of software artifacts that we call topics. And each topic includes all of the packages that are needed as dependencies for that. And extras essentially provides us the ability to provide you with bleeding-edge software on our stable supported base OS that gets long-term support, thereby allowing you thereby preventing this need to trade off between OS stability and software freshness. Now again, I'm going to switch over onto my demo console to give you a quick demo of extras in action. Oops. So I have a demo virtual machine spun up here on, I think, what's an M5 large. I am, again, going to take a moment to increase the font size here so that it's visible. So now if I run sudo Amazon Linux extras, what you'll see here is a list of what we call extras topics. So each of these is a software topic that includes all of the dependencies to make it happen. For example, we have an extras topic for a LAMP stack that includes the right version of MariaDB and PHP and the Apache web server and all of that. We also have things for extras topics for GUI software like the Mate desktop environment, for LibreOffice, etc. I mentioned Corretto earlier, so we have Corretto, our first-party Java or OpenJDK distribution, also made available as an extra. And there's no shortage of topics here, including Firecracker that I'm going to show you shortly. So if I did want to install an extra, for example, let's say I wanted Corretto, which is the AWS Java, the OpenJDK distribution, I'm going to go say sudo Amazon Linux extras Corretto 8. Whoops. I forgot install. So there, it's going to pull in all of the dependencies. And boom, I have Java installed. I can go ahead and use that. Now, extras also provides us with a mechanism to enable you to run multiple versions of the same software and have them exist concurrently. For example, if you look at Docker here, we offer multiple versions of Docker CE. And one of the things that I'd done previously is I'd gone ahead and installed Docker and had Dockerd running and things like that. I also mentioned that Amazon Linux was available as a Docker base image. So you can go do things like, so Docker is already enabled and pre-installed. I'd pre-configured it before this session. So you can do things like sudo docker pull Amazon Linux, and then I specify a tag too, and then it'll go fetch it from Docker Hub. It's there, so if I do docker images, whoops, sudo docker images. So I noticed that there, and then it's a Docker environment, so I could pull in any other Docker base image, Arch Linux or Ubuntu or whatever else. Just for the purposes of this exercise, I'm going to run this container inside Amazon Linux. So I'm going to say sudo docker run in interactive mode, and then choose the image ID, and now I'm inside the container. So I can say uname -a. I can run my commands, whatever those are, and then I can exit out of that container. So this is just a sampler showing you the use of extras, and I can go ahead and uninstall extras in a similar manner. But the real takeaway is that it provides you with a mechanism to consume the latest application software. We have databases in there, language runtimes in there, and we're constantly adding new topics. And if you notice a topic that, or if you'd like to see, if you want to use a topic or a set of application software artifacts via extras that you don't see there, get in touch with us. We have a long roadmap for what we want to make available with extras. But really the takeaway here is that you don't have to balance OS stability with software freshness. And the other takeaway is that you can run multiple versions of the same software artifact concurrently on your stable supported base OS. I'm going to switch back right now. I mean, we saw a Docker demo. We're also optimized for running container workloads. We have a variant of Amazon Linux 2 that we call minimal Amazon Linux that contains just the core capabilities of the OS, things like the kernel, glibc, etc. And this is the basis for some of our container-optimized images that we provide. So we have ECS and EKS that are our orchestration services, and these services make available AMIs, Amazon Machine Images, based on Amazon Linux 2 that are, again, optimized for running containers. And these include things like Docker, as well as the agents and components required to work with ECS and EKS as pre-installed components. In the case of ECS, it is things like ECS agent, which itself runs as a container, and ECS init, which is an initialization component. And for EKS, it is the requisite Kubernetes artifacts. We also have a Docker base image for use in any Dockerized environment. It could be on the AWS cloud. It could be elsewhere. And we just saw an example of a Docker pull of an Amazon Linux 2 image. The other thing to be mindful of here is when you run containers today inside of a virtual machine running Amazon Linux or most other operating systems, you're typically taking advantage of kernel capabilities for security and resource isolation. So the current mechanism that we use in Amazon Linux is things like C groups, is things like kernel namespaces for things like security and resource isolation. We also have capabilities around eBPF, the enhanced Berkeley packet filter, for doing interesting things around around having programmatic rules that run inside the kernel itself. But for the most part, we're relying on mechanisms like C groups, like kernel namespaces, like seccomp-based isolation, etc. The whole modality has been about running containers on a shared OS kernel. Now, one of the announcements that some of you all might have witnessed yesterday that I want to talk briefly about is Firecracker. And Amazon Linux 2's support for Firecracker. But before I get started, let me give you a brief primer of what was announced yesterday around Firecracker. Now, there's historically been this trade-off between security and performance. And performance includes things like startup times. It includes things like density when it comes to container hosting. You could host multiple containers on a shared kernel, but there are challenges when it comes to security isolation and resource isolation, especially in hostile multi-tenant environments. If you're running your own containers in a tenancy boundary that you control, then maybe a shared kernel will suffice. But if you're running it in a hostile multi-tenant environment, as is the case with many of the services we run, like Fargate, like Lambda, etc., that's not something that we can afford to do. So as was mentioned earlier, we have historically erred on the side of running these workloads inside of virtual machines and using the virtual machine tenancy boundary and isolation model to be able to host customer workloads and not have workloads from multiple customers exist within the same tenancy boundary. That places challenges when it comes to startup times, when it comes to density and things like that. Virtual machines certainly take longer to come up than containers do on an OS kernel. So however, they provide the requisite security that you need for hostile multi-tenancy. So Firecracker is an innovation that is from AWS, and we've also open sourced it under the Apache license that essentially allows you the ability to create micro virtual machines. We call them micro VMs. So these are still hypervisor partitions backed by VTX and hardware support for virtualization. But at the same point in time, these are micro versions of the virtual machines that are best suited for running workloads like containers or Lambda functions and things like that. So this is, again, if you think of this spectrum where you have a user space process on one side and a virtual machine on the other end of the spectrum. This would be somewhere in between that spectrum that gives you the best of both worlds. The requisite security for hostile multi-tenant operation, as well as the necessary performance, such as rapid bring up of artifacts. And these artifacts in question here are micro VMs, and they could be used for hosting things like containers or Lambda functions and things like that. Now, that is about Firecracker, but the relevant part here that ties into Amazon Linux 2 is that we've made Firecracker available for use on Amazon Linux 2 and we've packaged that up as an extra. So enabling Firecracker on Amazon Linux 2, if you do have workloads and use cases where Firecracker can suffice your needs, is as simple as spinning up an EC2 bare metal host and then going and installing Firecracker through extras. And I'm going to demo some parts of that shortly, but it is important to note that this is intended for use primarily on EC2 bare metal, because EC2 bare metal gives you access to the underlying virtualization primitives that are needed for Firecracker. I mentioned earlier that you can use KVM with Amazon Linux 2 to do your own virtual machine hosting on EC2 bare metal. The concept with Firecracker is very similar. So I'm going to quickly switch over into my demo machine here. And log into Amazon Linux 2 that I'd spun up earlier on an EC2 bare metal system. Again, EC2 bare metal gives you a physical machine and not a virtual machine on top of virtualization stack. Let me go ahead and increase the size of the text here. Now if I say sudo Amazon, Linux extras, so it's going to list the catalog of extras. I'm going to install sorry about that sound. Install Firecracker. So it's installing Firecracker, and boom, it's installed and enabled. One of the things that we've also open sourced, in addition to the core Firecracker micro VM technology, is an SDK written in Go that allows you to speak to Firecracker and create micro VMs. And the Firecracker has a REST API surface, so I can come up with REST calls that I can hand construct with Rust or with curl, where I create a put request and then say, all right, create me a micro VM with these many vCPUs, this much RAM, et cetera, and then provide an instruction to start it up. Or what I can do is just use the friendlier tool that we call Firectl that is also open sourced and on GitHub right now to do that. So one of the things that I'd done previously is that I'd downloaded the sources for that. I'd built it. I'm talking about Firectl. So I'm just going to go. Oops. Let me turn off the volume. My apologies. Give me a moment. I'm just trying to figure out this directory structure. Sorry. So this is the firectl command. So essentially, to start up a micro VM, what I'll need to do is, these are the options that I can use with the command, but I'll have to point to the Firecracker binary that I installed via extras. So if I do a which Firecracker, I'll go find the binary. And then I'll also have to supply a kernel image for the guest micro VM that I'll have to create, in addition to things like the root partition and things like that. Now, I'm looking at the time right now. So what I'll do is I will defer the usage of Firecracker to later. In fact, you can come find me after the talk. I know this is advertised as a 200-level talk, so I don't want to get too much into the nitty-gritties. But it is as simple as coming up with a command to point to the right Firecracker binary, pointing to the kernel image that you want to launch inside the micro VM, along with the right settings, and then boom, you have your micro VM. To actually go ahead and do this, I will have to go SCP a kernel image that I have locally into this virtual machine and start that up. I will defer that for later. You can come find me after the talk. I'm happy to go over that. But I want you to know that Firecracker is supported in Amazon Linux 2, made available through a one-command installation via extras, and yeah, you can run micro VMs on EC2 bare metal. You can also take advantage of Firecracker by building it locally in your own on your own physical machines in unvirtualized environments to host your own micro VMs. It's an open source project. Switching back, Amazon Linux 2 is also available for on-premises use. Again, this is a first for us. We've made it available for use on VMware virtualization hosts, on Hyper-V, on KVM, on VirtualBox. And if there are other virtualization platforms that you use where you would like to see Amazon Linux, but you don't see it as a supported platform or as a platform that it works on, come talk to us, and we're happy to add that onto our list. Again, the security update story is the same as Amazon Linux 2 in the cloud. It will be supported until June of 2023. And it's also available at no cost. In fact, you don't even need to be an AWS customer to download and use the Amazon Linux 2 virtual machine image on your favorite virtualization host. Now, we're recommending this primarily for development and test use cases where you can run it locally on your laptop or on your dev machine, perform the dev test, and then ship it to the AWS cloud for production use. This has also helped with lots of use cases, especially when we've gone ahead and approached ISVs and partners to test and certify their applications for use on Amazon Linux 2. In many cases, their test harness and setup was mostly on-prem, and they were able to use the Amazon Linux 2 virtual machine images on the virtualization host software that they had to be able to get certified and on their local on-prem environment, and then, of course, test it on AWS. Now, again, I'm going to switch over into a demo. Like I said earlier, it's hard to demo an OS. So what I'm showing you is all the environments that it can operate in. So one of the things that my standard issue Amazon IT x86 laptop running Windows 10 has is this module called Hyper-V. So Hyper-V exists for servers. There's also a client version of it that exists on client devices. So you can go ahead on Windows 10 and enable it on control panel. I've done it before this session, so Hyper-V is enabled. It puts your laptop through a reboot. It, of course, needs things like hardware support for virtualization, things like VTD, VTX to be supported, which in this case is true. So I have Hyper-V Manager enabled here, and this is What I had done previously is I had downloaded an Amazon Linux 2 image from the AWS website for Hyper-V and spun it up here. So I'm going to start that here and connect into my Amazon Linux virtual machine that is running locally on my laptop. Again, this is an example of, choose the right image, yeah. And this is an example of me being able to do dev test locally on my laptop using Amazon Linux 2. This could be your on-prem server where you're running a server with certainly much more CPUs and much more RAM than I've allocated to this virtual machine on my laptop. You'll also notice that this is optimized for running on this virtualization host. So things like dynamic memory, which is a host capability, is enabled, and there's a ballooning driver inside of Amazon Linux 2. It's called Linux Integration Services from Hyper-V that is pre-installed and pre-configured. So you might notice messages on the screen that is talking about memory or the ballooning driver at work, where it sort of takes up and gives away memory. So I'm just going to quickly log in here. The login name is still EC2 user, although this is not running on EC2. You'll also notice some ASCII art that says EC2, but it's, as you can see, it's running locally on my Hyper-V installation on my laptop. Oops. That's the ballooning driver message that was. There. So if I do uname-a, so this is running locally on my laptop using the on-prem image. And again, this has the same capabilities as Amazon Linux 2 in the cloud. And the same is true for VMware and VirtualBox and things like that. In fact, what I've done is I've been able to use laptop Wi-Fi to create a virtual switch that I've been able to attach to the virtual machine as a networking device. And you can access the network from within the virtual machine. I'm going to switch back into presentation mode. So that was on-prem virtual machines with Amazon Linux 2, a new capability that we've put out. Amazon Linux 2 is also available in this cloud desktop form factor. So we have this service, an AWS service that's called Amazon Linux Workspaces, where we provide managed cloud desktops with Amazon Linux 2. You might remember when I showed you that catalog of extras, there was an extra for Mate desktop environment. So in the cloud desktop, Mate is enabled by default, and it's a virtual machine running for you in a fully managed manner. It comes with a pay-as-you-go pricing model. Workspaces also has client software for things like Windows laptops, for Macintosh systems, for iPads, for Android devices, things like that. And you can use one of those to log in. So I'm going to show you another quick demo of Workspaces in action. So this is the Workspaces client that I had pre-installed. Now I'm going to enter my super secret password. And voila, this is Amazon Linux with the Mate desktop environment. This is as much eye candy as you can possibly get for an OS demo. So if I say cat system release, it says Amazon Linux 2. There's also productivity software that we've bundled in via extras and made available. So there are things like LibreOffice, Firefox, GIMP for image editing, et cetera, et cetera. Now you can go to Amazon.com, check out deals that still exist. I know what I'll be doing after this talk. The other thing, since we're in a web browser, I also want to show you Amazon Linux, the security patching story in terms of security advisories. So we also have this thing called the Amazon Linux Security Center for both Amazon Linux 1 or Amazon Linux AMI and Amazon Linux 2. So all CVEs that we've patched would be listed here, so you can go get the details of the patching information and all of that. So this is a website that we keep up to date, and it lists the security patching story for Amazon Linux 2. Switching back. Now, we spoke about Java. There are lots of customers that are currently on Windows Server running line-of-business apps with .NET Framework. And we've heard from a lot of customers that there is a need and a desire to move from using .NET Framework to using .NET Core. Now, we've made available AMIs, Amazon Machine Images, with Amazon Linux 2, with things like .NET Core, with things like PowerShell Core, with things like the AWS command line interface pre-installed and pre-configured. So you can run your applications built for .NET Core on Amazon Linux 2. And we've made AMIs available for this purpose. PowerShell Core 6.0 provides a shell and scripting experience that might map on very closely to what you're familiar with on Windows. And additionally, we also have an AMI with SQL Server for Linux. This is SQL Server 2017, Web Standard and Enterprise editions that, with those components pre-installed and pre-configured for use on Amazon Linux 2. Next up, I want to talk about our ISV ecosystem story. We've heard your feedback. We're working with a large number of ISVs to ensure that their software is certified and compatible and supported for use on Amazon Linux 2. What you see on your screen is a subset of ISVs that we've worked with. We're in touch with a much larger number of ISVs. And the feedback that we've heard for the most part is that it was fairly easy to get started and have their software supported on Amazon Linux 2. So if there are ISVs that you know of that whose software is important for your business, and if that is an influencing factor for your OS decisions, come talk to us, and we're happy to look into prioritizing the ISVs that you care about. And with that, I want to transition off briefly to Galen from Chef, who will talk about their experience with certifying on Amazon Linux 2 and what it brought them. So Galen?
Thanks.
Yeah.
Testing. All right, good, we're good. Yeah, thanks, Martha. And so really, what we wanted to talk about here is about why we care about being an ISV with Amazon, and particularly why we cared about getting certified on Amazon Linux 2, and what really this operating system does to open up for us as a vendor. And the key is that by certifying on Amazon Linux 2, when you're using Chef and Amazon Linux 2, you get full support, either from us or from Amazon. We know that our tools are going to work with each other. We know that things are going to operate the way we want to. And there's no blame game. There's none of those fun games of like, oh, you got to call the other guy, blah, blah, blah. We know and work with it really well. And this isn't the only time and place we operate within Amazon, right? AWS OpsWorks is backed by Chef under the hood, doing a lot of really great things and things like that. And if you're not familiar with us and what we do, what we're really trying to solve is when we're trying to look at these new operating systems, right? You're looking in this room and you're saying, hey, Amazon Linux 2 looks really great. I want to start transitioning to that. How do I start making that happen? How do I start getting into this lift and shift? Or how do I get into DevOps? Or how do I kind of get into cloud migrations? How do I go faster? How do I do it safely? Things like that. Really what we want to come in and say, hey, the way to make that happen, the core structure of how we operate in today's world to manage the complexity of our systems is really just to say everything should be code. Which is to say the infrastructure, how we build it should be code, the compliance and how we make sure our systems are secure and safe should be code, and obviously our applications are code, but in particular, how we build and deploy all these things should absolutely be codified into a process, right? This is often called SDLC, continuous integration, continuous delivery, you name it. And the core idea of how we operate and what we do with our customers and the results we see from things like this is to say, hey, if I'm running on a different operating system right now and I want to transition to Amazon Linux 2, but I built that system by hand, and I only know it because somebody in the back room is the one who built it. It's all in their head, or maybe it's in documentation, but it's it's a little out of date, right? Because documentation never gets updated quite at the same rate it should do. And so we really want to codify that. That's what we do at our core. Is we're Chef. I suspect many people in here have heard of Chef and probably use Chef. And that's really what we do. We solve the infrastructure problem. We say, how do we build a system from the base image to a thing that can actually run our workload, right? Because at the end of the day, we don't actually care about the operating system itself. We care about delivering the workload, delivering the project, delivering the product to our customer base, right? That's the business value that we're all trying to drive towards. And so that's what we do on the first part, and that's a key component, right, is to codify that. I'm sure many of you people are already thinking about how you build this into your image pipelines, how you do those things. Really great experiences. We love all of our customers who do that. The next thing that's really important in terms of this space and how we operate is how do we make sure the system stays compliant, right? Amazon Linux 2 is a highly secure, highly scalable operating system, but we need to make sure that we stay compliant, right? And so one of the key components that we do at Chef is we have a tool called Inspec, and we have a bunch of Inspec profiles, compliance profiles, built specifically around the CIS benchmarks, including one for Amazon Linux and Amazon Linux 2. So the CIS benchmarks, we can use and scan our systems remotely or directly on the system to verify if the system is in compliance and really achieve continuous compliance. And so what we found in this is we've got customers who have driven down their compliance audit times down over 90%. They're able to automatically look when an auditor comes in the door. They can show them a dashboard and say, look, here's my proof that I am compliant today. I don't have to go look at all my systems. I don't have to go hand by hand. I can make all this happen as I go through the process. That's the key component here. And what we want to do here, we're working with Amazon, is this really helps us unlock the ability to go to Amazon Linux 2 quickly and efficiently by codifying all these things beforehand. These basically just become software tests that we can run and verify our systems before we go try to deploy to production. And by doing that and codifying that, we can build this into the pipeline. And the last thing I want to talk about real quick is another tool we have called Habitat. This is really the last component is that these are all great components to get infrastructure up and running, but what we really care about is the application stack. And like I said before, everything is code. We want to really make sure we build everything as an artifact. That's how we get safety going through our pipeline. Long story short is to say, I want to create an artifact that is the thing I care about, either a compliance profile, an infrastructure configuration, or an application configuration at a moment in time. And that's the thing I'm going to move forward into my system. And the way we do it with Habitat is we create a locked artifact that is explicitly everything that the application needs to run, so we can run it irrespective of runtime. The great part about this, as Samartha was showing in terms of local development, it's really critical that we get consistency across our fleet, right? One of the key things I'm loving about Amazon Linux 2 is that I can run the same operating system both on-prem in my Hyper-V environments, in my VirtualBox environments, but also up in Amazon and even on VMware. So I can really make sure that I get the same consistency across the whole fleet, and that's exactly what Habitat's trying to do with the application stack, which is to say, I don't really care as an application what operating system is underneath me, but I know that I care about that from the infrastructure side already, but the application itself is going to be able to run irrespective of the runtime. And we can also make sure that the application runs in a container by post-processing into Docker. So those are the core components of what we care about at Chef and why we're here, why we do these things. One of the reasons we love AWS and Amazon Linux 2 is that it really helps solidify that message of, look, we're going to get consistency across our entire fleet, and we're going to do it by defining things as code, and we're going to bring an artifact forward and move that artifact through the pipeline, whether that's our base image, whether that's our compliance, or whether at the end of the day it's the actual application itself. And that's all I have.
Thank you so much, Gail. So that's our ISP ecosystem story. Again, we're looking to expand this in a substantial manner, and if there are ISPs that you depend on that are yet to be certified on Amazon Linux 2, come talk to us, and we look to prioritize them. Lastly, I want to talk about upgrading to Amazon Linux 2. Now, we have this thing called Amazon Linux Pre-Upgrade Assistant. So this is a tool that is meant for running on Amazon Linux 1 or Amazon Linux AMI, in case you already have an Amazon Linux AMI fleet. And what it'll do is that it'll go ahead and flag any incompatibilities and inconsistencies that exist between Amazon Linux AMI and Amazon Linux 2. Now, one of the things we do is on the latest supported major release of Amazon Linux AMI, that is 2018-03, we run Linux kernel 4.14. So on the kernel front, there should be fewer sort of wrinkles, but there have been changes such as there's a different version of glibc. Amazon Linux AMI uses init. Amazon Linux 2 uses systemd. Things like that. So if there are known changes, this tool will run on your Amazon Linux AMI installation, flag any known issues, and provide mitigations as suggestions of what you can do with Amazon Linux 2 to find the closest equivalents. Additionally, this tool is open source and on GitHub right now. So this is implemented as modules, and we look forward to your contributions to enhance this tool, perhaps add support for additional platforms to move from those platforms to Amazon Linux 2, etc. But Amazon Linux AMI will be supported until June of 2020. So this is the last major release of Amazon Linux AMI or Amazon Linux 1. And with the pre-upgrade assistant, we want to provide you with an easier way to transition your workloads that might already be on Amazon Linux AMI to using Amazon Linux 2. We're reaching the end, so I want to leave enough time for questions. So I want to quickly summarize. The top takeaways with Amazon Linux 2 is there is long-term support. So it's now supported for 5 years, and this not just includes security updates and maintenance fixes, but also binary compatibility, and specifically ABI compatibility for a core set of packages. We also have premium support options from AWS support, and if you already have an AWS support plan, then Amazon Linux 2 premium phone support is included at no additional cost. Extras provides bleeding edge application software on a stable supported base OS. It is optimized for use on AWS, especially EC2. We just saw the demo of Amazon Linux 2 working on the new A1 instance type, as well as including support for things like Firecracker. It is universally available, not just on the AWS cloud, but also for use on premises. It is also available as Amazon Linux Workspaces, which is a managed cloud desktop environment. And then we have a robust ISV ecosystem story as well. And best part of all, it's available at no cost for use both on AWS as well as on-prem. I want to leave you with a few resources. The Amazon Linux engineering team and myself, we're here at reInvent. So if you want to follow up with us, if you have detailed questions, if you're thinking about moving to Amazon Linux 2, come talk to us, and we're happy to sit down with you and go over your specific scenario and see what the best options are. There are also a bunch of related sessions. There is specifically a session that I want to draw attention to, the CON404 session. It's oddly named, but it's the care and feeding of Amazon Linux. This is from an engineer on our team, and it goes over into the details of how we build Amazon Linux, what our sources are, where the process that we follow to build an OS, to support it, to maintain it, to address things like security fixes, et cetera, et cetera. It's a very detailed technical session, but I want to draw attention to that. There are also other sessions related to Amazon Linux Workspaces, both a breakout session as well as a builder session. And really most sessions that you'll see with, be it EMR or be it Lambda or be it ECS, EKS, there'll likely be some aspect of Amazon Linux, since it is sort of the basis for the runtime for a large number of AWS services. I've left you with a bunch of web links, and I want to open it up for questions. I think a mic will be passed around, so feel free to ask questions. Like I said, my name is Samartha. My email address is on the screen. Thank you so much for attending, and feel free to, it's open for your questions right now. Thank you.
Hi. Are the extras or the other packages that you provide available for the ARM processor as well as the Intel side of things?
So the question is, are the extras also available for the A1 instance type? I think the proof is in the pudding. So why don't we log into the A1 instance type or the Amazon Linux build on A1 and then find out for ourselves. So whoops. Let me switch over onto this sudo.
Center. Yep.
So there you go. So this is extras. Admittedly, not all extras are available. For example, Firecracker is not there. That is available only for x86 on EC2 bare metal. Just to ensure that this is on the ARM instance type, I'm going to do an ls CPU, so you know it's on ARch. So yes, so extras are available for Amazon Linux on ARM as well, or Amazon Linux 2 on ARM. Again, it is only the set of extras that are applicable for that environment. Again, we're looking to provide parity there and things like that. But yes, are extras available? Yes, they are. It might not match one-to-one. Yeah, thank you.
Hi. You had on the, over here.
Oh,
you
all right.
had on the ISV pages HashiCorp. Any idea on roadmap of where a Vagrant base box might be?
Sorry, could you say that again?
A Vagrant base box? Sorry.
The question is do we know if HashiCorp is going to be building a Vagrant-based box?
No, if there would be an Amazon-blessed base box.
Sorry. Yeah.
Yes, they are a valued partner. We're working with them. Not all scenarios around Vagrant are documented. Now, there are certain community documentation artifacts where people have tried it and put it out. Yes, it is on our radar, on the list of things to do. There are lots of other HashiCorp products that are certified for use in Amazon Linux 2, Packer and Terraform and a whole bunch of other things. But yes, better story with Vagrant is certainly on our radar. Thank you for that.
Just to add to that, Chef publishes a number of Vagrant-based boxes ourselves for Test Kitchen and a couple of tools that we build and maintain in our space. I don't know for sure if Amazon Linux 2 has made the list yet, but as it's one of our core build pieces as our pipeline, it should be there shortly if it's not already. Fair enough.
Hi. Thanks for a great talk. It's pretty interesting stuff. Can you guys think of maybe just a simple example of something that people are currently doing in containers that would be a good fit for Firecracker?
Certainly. Now, the best example that I can allude to is things that we've already announced, which is that our own services, such as Firecracker, Lambda, Fargate and Lambda use Firecracker under the covers, where multi-tenant isolation among containers is important. Now, the examples that I can think of are all along those lines, that it is, if you want, multi-tenant isolation, or isolation in conditions of hostile multi-tenancy without sacrificing performance and density. That would be, I'd say, the broad theme around use cases. I can, off the top of my head, think of several of those. If you're a managed PaaS service provider, et cetera, or depending on compliance stipulations, if you're a larger enterprise, these things could be applicable. But the theme around it is secure micro VMs without compromising performance. So you want a way to run. It provides you with a way to run containers or serverless runtimes in conditions of hostile multi-tenancy, where you don't trust the other tenant. But yes, we can chat some more about. I can brainstorm some use cases. It's an open source project, so we're looking for community contributions and needs to drive it forward as well. Yep.
Hello.
Yeah.
Quick question for you. In terms of, so we're building tools that will that works with several flavors of different flavors of Linux. Of your current install base within AWS, what is the current install base look like that's using or deployed with Amazon Linux today? And what do you expect with Amazon Linux 2?
I see. So this is a market segment share question. Again, we don't break out the numbers specifically. However, I can tell you that a very large number of usage is from Amazon Linux AMI and now Amazon Linux 2. There is a transition there. You'll also notice that a large number, if not the vast majority of AWS services provide AMIs based on Amazon Linux. It could be ECS, it could be EKS, it could be EMR, and under the covers you have things like Lambda, things like Elastic Beanstalk, etc. that are all powered by Amazon Linux. So if you add all that up, it is a very large number. We don't break down sort of that explicit distribution per se.
Hello.
Yep.
I appreciate the session. So we develop an agent for both Amazon Linux 1 and Amazon Linux 2. And I was wondering if there's a specific method or URL or email address that I can use to get those agents certified.
Certainly. You can reach out to me. Feel free to reach out to me. We're happy to work with you. We're looking to expand our ISP certification story. So let me sort of switch over to the previous slide that has some contact information. So yeah, just drop me an email, or after this talk, I can come find you, and then we can chat some more. Yeah, thank you.
Hi, quick question on the extended libraries. I noticed that Python 3 was end of life, and then now it's removed. What happens now? Do we just yum install? Is that the recommendation?
Yes. So the core set of libraries, you can install artifacts via yum. So you would do a yum install of whatever artifact, and then you would get that. With extras, we certainly make additional packages available that you will have to use the extras command. If you attempt to do a yum install of an extras topic, you'll get a message saying, use it in this manner, extras, or Amazon Linux extras install that artifact.
So it's just the preview. Extras is really a preview.
Not necessarily, no. It's not a preview. It certainly does not get 5 years of long-term support. However, we map closely to whatever the upstream is, and we provide security updates for all of those artifacts. So. All right. Looks like we're out of time, but thank you for attending. And again, I'll be floating around here after the talk, which is right now, and happy to chat some more.